So today we are going to talk about the topic that's what we call density, okay? And then it's under the title that's what we call density, mass, and volume. If you remember grade 10, term 2, natural science, okay? And then we talked about mass and volume, and then I think we did enough for the mass and volume, and now we are going to use the knowledge, the background knowledge that we learned about then mass and volume to be able to identify density, okay? And then talk about the difference between the densities, okay? Talk about the difference between the densities of different substances, okay? So we will not only talk about the solid, we can also talk about the liquids also, okay? Let's see what happens. And then when you look at this slide, it's on Google Classroom, you can easily use these slides, okay? When we look at the definition of density, when we look at the definition of density, that's the amount of mass given in a volume of matter, okay? So which means that, I just would like to give you two examples, which means that you have 1 decimeter cube of volume of something, okay? What is the mass? It is what we call as the density, okay? That's what we call, one is what we call unit, okay? And then you have unit volume of, okay? Unit volume of something, okay? For example, a piece of wood, okay? And then a piece of box, okay? For example, a piece of iron, metal, okay? So when you take 1 decimeter cube or 1 liter of this, okay, what is the mass of this? That's going to tell us about density. If the mass is higher, density is higher, okay? If the mass is lower, density is lower, okay? And then when we look at the formula for this, I'm not going to focus and then talk about details about this formula. And I just would like to show you how to calculate density of something is in natural science is what we call is the mass over volume, okay? You take the mass of a substance divided by volume of substance, and you know that the mass is in kilograms, okay? Or grams, okay? We usually use kilograms and grams, that's what we discussed for the mass. You remember from the previous classes, these are the assignments. And then for volume, if you remember, we are using a decimeter cube or centimeter cube, okay? That's what we discussed. These are the units, okay? So you take, find out you have a piece of something, okay? Piece of an object. For example, piece of wood, as you see here. And then what happens is that you just measure that what is the mass, okay? Put it on scale, and the mass is, for example, 1,000 grams. And then you measure the volume, okay? You can measure the volume in different ways that we discussed. If it is and if it's a shape that we can identify, we can easily find it, calculate it by measuring it. Or if it's the shape that we cannot identify, and then we can use the displacement of water as I discussed in the previous videos, okay? And then you take it and, for example, it's 250 centimeter cube. And then what you need to do is that 10,000 grams divided by 250 centimeter cube is going to give you the density in grams per centimeter cube, okay? So grams per centimeter cube, okay? That's how I show grams per centimeter cube, or grams divided by centimeter cube, okay? Grams divided by centimeter cube. Okay, that's what we call as the unit of density, or kilograms divided by decimeter cube. Okay, that's also, so which means that if you have 1 centimeter cube volume of something, what is the mass in grams? Okay, if you have 1 decimeter cube of something, what is the mass in kilograms? Okay, so you take the volume and then you look at the mass of it. Okay. And then to be able to identify, okay, to be able to compare the masses, compare the densities of different substances. One method that we use, okay, one method that we use is the one in the bottom, that diagram, okay. Each cube made up of different material, as you can see that cubic structures. And imagine that all of them, they have the same volume, 10 centimeter cube, 10 centimeter cube. 10 centimeter cube. One is made up of sponge, okay, that we are using for washing dishes, okay, for example. And the other one is the wood that we are using for furnitures, any kind of wood, okay. And then the other one is, that's what we call the iron, okay, piece of iron, pure iron. It's a metal. But they all have the same volume, but different masses. How do I know they have the same volume, different masses? For example, you can just hold it, you can see that iron is heavier than other two. okay? Another way of doing is that you have a container. Into this container, you put a same amount of water. For example, 1 liter of water in each, okay? Initially, okay, they must be same. It's not same, okay? The level of water is not same. Why? Because one has more displacement than other one, okay? One goes in, okay? Sinks in more than other one, okay? One floats more than other one. That's the reason, okay? As you can see, the levels are not same. Initially, imagine that we don't have this piece of substances, and then you have the same amount of water in each. And then you put into one is 10 centimeter cube of sponge, other one is 10 centimeter cube of wood, and the last one is 10 centimeter cube of iron, okay? And then as you can see, there is that the sponge is going to float on it, okay? On the top of the water, surface of the water, and the wood is going to also float, and then iron is going to sink at the bottom. It's just going to sit at the bottom. So I can easily say that iron has more mass, that's why it sinks at the bottom. What about comparing these two? Okay, how can I compare these two? If they float, which means that they have less density, so they cannot overcome the pressure coming from the liquid, and then they will just float on the liquid. And then what we need to say is that, as you can see, how many percent of the wood is inside of the, okay, inside of the water, okay, sinks, how many floats on the water, like half and half, 50%, 50%. When we look at is 1/3 of the sponge is, 1/3 of the sponge is in water, and then 2/3 is outside, okay, it floats on it. So if there is more part of it, okay, if there is more part of the substance inside of the water, which means that it has higher density, okay? So when I look at here is that they have the same volume, but this one is like 5 centimeter cube is inside of the water. How do I know 5 centimeter cube? Half of it, okay? And for this one is like around 3 centimeter cube inside of the water. So which one has more inside of the water because of higher mass? The wood. So we can say that the more that substance sinks, okay, it has more density, okay? That's how we can compare. So which means that if I would like to compare the density of iron, wood, and sponge, if you put it on a water, okay, and then the one that sinks at the bottom has the highest density. After that, wood, because there is more amount of wood under the water than, okay, when you compare with sponge. And then the last one is the lowest density is the sponge. That's how we can compare their densities. Another way of comparing densities is this one, okay, and then I'm going to show you some calculations. In the second case is that what we have is that we have different solids, okay, magnesium, aluminum, and tungsten. Okay, tungsten is the one that we are using usually for the light bulbs, okay? So these are different metals, magnesium, aluminum, and tungsten. And then what you do is that now you don't take same volume, okay? You take same volume, sorry, you still take the same volume, okay? These are solids with the same volume, but different masses, okay? So as you can see that you take a piece, 10 centimeter cube, 10 centimeter cube, 10 centimeter cube. And what you need to do is that you just put it on a scale, okay? You put it on a scale. And then when you put it on a scale, you see that the first one, the magnesium shows you 92 grams, aluminum shows you 142 grams, and the tungsten shows you 1015 grams. It's almost like more than 1 kg, okay? And what we need to do is that say that if they have the same volume, which one has higher mass is going to have higher density. So I can say that the density of tungsten is more than aluminum is more than magnesium. So which means that if you have solids, they have the same volume but different masses. The one with higher mass will always have the higher density. Okay, that's how we can understand. And also I would like to use this formula, density formula, and I want to calculate the density in grams per centimeter cube, okay, cubic centimeter. How can I do that? Very easy. Density is equal to mass over volume. What is the mass of the first one? Okay, 92 grams. And what is the volume of the first one? 10 centimeter cubes. 92 divided by 10, 9.2 grams per cubic centimeter, okay? So this one tells me that, if I cut a piece 1 centimeter cube, okay, volume piece, what will be the mass? 9.2 grams, okay? If I cut 2 centimeter cube piece, what will be the mass? 9.2 times 2? 18.4 grams, okay? So which means that this density formula tells me that if I have 1 centimeter cube, that's called unit volume, okay? And what is the mass? 9.2. If I have 2 times. If I have 3, 3. If I have 10, 92 grams, okay? That's how we can understand density. How can I calculate the density of aluminum, piece of aluminum, okay, that we have here in this case? Simple. Density is equal to, as you know, the formula mass over volume, okay? And the mass here is that we measured by putting on the scale, okay? And then it says that 142 grams, okay? And then what we need to do is that, okay, and divided by 10 centimeter cube, okay? 10 centimeter cube is the volume, we just said that, okay? And then 142 divided by 10, if you use your calculator, you will get that 14.2 grams per cubic centimeter. So which means that if I cut a piece that is 1 centimeter cube, 1 centimeter cube piece, and it's going to have a mass is equal to 14.2 grams. That's what we call as a density. What is the mass of unit volume? Unit volume is 1, okay? What is the mass of 1 centimeter cube of this substance? Okay, it's 14.2. What is the mass of 1 centimeter cube of magnesium? 9.2. So which one has more mass in the unit volume? Okay, aluminium. Okay, so which means that aluminium is the higher density one. Okay, what about the last one? Is the tungsten? We use it for light bulbs. Okay, there's the metal in the light bulbs that glows. Okay, as you can see, it has higher density. How do I know? They have the same volume and the higher mass. When you compare with others, it's like almost like 10 times and then more than the other one. And then when we look at this calculation in the bottom, okay, I did the calculation for you. What is the formula for density? What was the formula for density? Okay, what am I doing? Okay, what was the formula for density? I just would like to highlight this. Okay, density is equal to mass over volume. What is the mass? We just measured, put it on scale, and then 1015 grams divided by the volume is 10. And then if you put it on your calculator, let's use our calculator. Where is my calculator? Okay, now you can see the calculator on your screen if I'm not mistaken. Okay, let's check one more time. Okay, you can see this on your screen. So it is 1015, okay, divided by 10. That's equal to, I just would like to show 101.5. 101.5. Look at here. As you can see on your screen, 101.5. So which means that, okay, as you can see here, which means that if I take a piece that's equal to 1 centimeter cube, okay, this one tells me that 1 centimeter cube, what will be the mass of 1 centimeter cube piece from this sample? 101.5 grams. So which one has higher mass when you take 1 centimeter cube piece from each? The one that is highest mass, okay? So that's what we call as tungsten has higher density than aluminum and then magnesium. And that's how we can calculate the density of solids, okay, by using the simple formula. What is the formula? Mass over volume. So if I use grams, what must I use the unit for the density? Centimeter cube. If I use kilograms, okay, what must I use for the volume? Okay, I should use decimeter cube, okay? We don't use grams and decimeter cube, or we don't use this is centimeter cube and kilograms, okay, together. So if you use grams, you must use centimeter cube, and if you use kilograms, you must use decimeter cube. That's how we are supposed to do it. And what about this example? This is another example that I found on the internet, okay, another example that we see here. Okay, it's a bit more complicated, very easy. These are some identified shapes. This is what we call cube, okay, cube. And then how do we calculate the volume of a cube? Okay, it is 2, as you can see, 2 centimeter cube. And this one is also 2, this one is 2. 2 times 2 times 2, 8 centimeter cube. Okay, that's 8 centimeter cube. And imagine that all of these structures, they have the same volume, 8 centimeter cube, 8 centimeter cube, 8 centimeter cube, 8 centimeter cube. And then if you take 8 centimeter cube of charcoal, what is the mass? If you put it on scale, 16 grams. Glass, 25 grams. And the copper, 87 grams. Iron, pure iron, 77 grams. And wood is going to be 8 grams. So what do I need to do before I talk about the density of each? I just like to show you that. So if I have the same volume, which one has higher mass? And then that one has the highest density. So I can say that which one has the highest density? You can easily tell me. Copper. Which one has the lowest density? You can easily tell me. Wood. Because they have the same volume, same unit of volume. That's what we call 8 centimeter cube, but it has less mass. Okay. So that is what we call as density. Okay. So I just would like to calculate the density of some of these. Okay. I just don't want you to forget this. Okay. Don't forget this, please. So the first one, when I talk about charcoal, okay, that is 16 grams. Okay. 16 grams divided by 8 centimeter cube. You remember that? What is 16 divided by 8? I'm sure you know about this. That is equal to 2 grams per decimeter cube. So centimeter cube. Okay. Can I just write it? Okay, just grams per centimeter cube. Okay, that's what we call grams per centimeter cube. And what about the second one? How can I calculate the density of the second one? Very easy. Another easy one. 25 divided by 25 grams divided by 8. Okay, and then I would like to take you to the I would like to take you to the Mr. Calculator. Yes, Mr. Scientific Calculator is going to tell us what to do. So we said that that is equal to 25 divided by 8, and then that's going to be equal to 315. Okay, can we go back here? 315. So this one is going to be, okay, everything goes, I don't know where is it called, 315. So this one is 25 divided by 8 is equal to, what is that equal to? I just like to check one more time. 3.125, okay? 3.125 grams per centimeter cube, okay? And then you can calculate others by using this. And then what you can do, you can even compare the densities by finding the densities, okay? So that is how we can find the densities of different examples, okay? Let's look at another slide, okay? I just would like to take you to another slide, another example. Now, different case, we used to have different, so same volume but different mass. But in this case, when you look at this slide, what you see is that we have the same mass, as you can see, same mass, 10 kg, 10 kg, 10 kg, but different volumes. What is the volume here? 1 centimeter cube, 2 centimeter cube, 10 centimeter cube. So the solids with different volume, but same mass. So how can I compare the density in shortest way? How? You use this, okay? What we need to do is that, so if they have the same mass, and which one has more volume, that one has less density, okay? So which one has more volume here in this case? Highest volume, the sponge, okay? That one has the lowest density. Which one has the lowest, the smallest centimeter cube or the volume? That one has the highest density. So what happens is that you have smaller volume, and then there is more density, and you have higher volume, there is less density, okay? That's how you can calculate. Or what you can do, you can just do simple calculation. I'm just going to show you a simple calculation. So can I just change these ones into decimeter cube? Okay, let's change this one. Okay, there's a mistake here. Let's fix it into decimeter cube here. It will be easy for us. I told you that if I would like to use kilograms, it must be decimeter cube. So now, when I look at the first one, if I use this formula, density, I'm talking about iron. Density is equal to mass divided by volume. Mass divided by volume. What is the mass of the first one, iron? 10 kg. Divided by volume, 1 decimeter cube. So that is what is going to be equal to 10 kilograms per decimeter cube. Can I just write it down here? Okay, very hard to type it. Very easy to use this. I don't know why. Kilograms per decimeter cube. Okay, I'm just trying to use my mouse. Okay, and the second one. How do I calculate the density of the second one, the wood, this piece of wood? And what we need to do, mass 10 kg divided by 2. Very hard question. You cannot calculate. I know that you need a calculator. Anyway, I'll give you the answer. 5 kilograms per decimeter cube. What about the density of the last one, the sponge one? And then that's going to be equal to 10 kg divided by, look at your screen please, 10. That's going to be 10 divided by 10. Everybody knows this answer. 1. So these are the densities. So which means that if I have 1 centimeter cube of sponge, what will be the mass? 1 kg, okay? And if I have 1 centimeter cube of wood, what will be the mass? 5 kg, okay? If I have decimeter cube, I'm talking about decimeter cube, 1 decimeter cube of iron, and what will be the mass? 10 kg, okay? So, which means that which one has the highest density? As you can see, 10, okay? And which one has the lowest density? That is the sponge, okay? So, which means that if you have different solids with the same mass, okay? Same mass, but different volume, okay? Same mass, but different volume. And what we need to do? We look at the one with lowest, smallest volume. Smallest volume is going to have highest density, okay? And the highest volume is going to have smallest density, okay? That's how we can understand. Or you can just do simple calculation if it is given, numbers are given. If numbers are not given, what you need to do, you just need to use this, okay? Solid with different volume, but about the same mass. One which has more volume has the lowest density. And the next one, okay, next one is a similar example. I found this one also on the internet. So you have 3 blocks, okay, as you can see, 3 blocks with equal volume, okay. For example, 1 decimeter cube, 1 decimeter cube, 1 decimeter cube. Imagine that, okay. And then what you do is that you put these blocks, okay. One is plastic that we use for example, how can I say, plastic toys, for example, the one that we use for plastic toys. Okay, the other one is a glass that we use for the glass that we drink water. Other one is the iron that we use for example, bowls, okay? And what you need to do, you just put them equal volume, you take the equal volume piece, and then you put them on a scale. You see that this one is 0.9 grams, okay? This one is 2.7 grams, this one is 7.8 grams. So by using this, how can I compare their densities? How can I compare their densities? They have the same volume. The one with higher mass is going to have the highest density. So we can say that iron has the highest density. And after that, glass has higher density. And the lowest density is the plastic, okay? Or what you can do is that numbers are given. What I will do is that I will just use the calculation, okay? And then imagine that each one is centimeter cube. Imagine the centimeter cube. Sorry, can I just clean up this? Centimeter cube. I just like to write here centimeter cube. Centimeter cube. Each one is 1 centimeter cube. And what you can do is that I would like to type here, okay, 0.99 divided by 1. Okay, what will be the density of this? 0.99 grams per centimeter cube. What will be the second one? So it is 2.7 grams per 1 centimeter cube. That's going to be equal to 2.7 grams per centimeter cube. What about the last one, iron, is that what we need to do, mass divided by volume, okay? Mass should be in grams. If it is in grams, the other one should be in centimeter cube. And then all of them, we said, say 1 centimeter cube. So that's going to be 7.8 divided by 1. That's going to be 7.8 grams per centimeter cube. So even you calculate, what you see is that there is a similar proportion between them, ratio between them, and then similar order between them, how I can say, put it in this correct word. Okay, this one has 7.8 grams, okay, this one is 2.7, and then 0.9. That's what we need to use to be able to compare the densities of these 3 samples. Why What about phase? Okay, this is another dimension that I would like to take it to you. Okay, for example, we compared the solids until this time, if I'm not mistaken. What about solid changes into gas? Solid changes into liquid, liquid changes into gas, and the liquid changes into solid. What happens to the density of a metal? I'm talking about one type of substance. For example, H2O, pure water, H2O molecules. So when the H2O is changing from gas into liquid, that's what we call as condensation, if you remember. When the liquid changes into liquid into solid, that's what we call as freezing. You remember this, okay? And then you cool down. That's how it goes from condensation into freezing. What about solid? You heat up solid, and then when you heat up solid, and then it starts melting, okay? Turning into liquid. When you heat up the liquid, when it comes to a point, that's what we call boiling point, and then it will start turning into gas directly, and that's what we call as boiling, okay? There's also evaporation during the meantime. We talked about this. As you can see is that you take the same volume of each, okay, sample, H2O molecules, and how many particles do we have in the gas? 2, 4, 6, 8, 10, okay? In liquid, it looks like 20, in the solid, it looks like 30, more than 30. So which means that if you take the same volume for each, which one has the highest number of particles? Solids, as you can see on the right-hand side. So which means that it has more density. You see, they can't fit it in the same volume. These ones, they have some free space between them. And then when we look at the first one, the gas, there is lots of space between them. So there is no, actually very small amount of density. So I can easily say that for most of the substances, usually what we see is that when something, a metal changes from solid to liquid, what happens? The density decreases, okay? When it changes from liquid to gas, what happens to density? Decreases. So which means that if the temperature increases, what happens? You go into less dense. If the temperature decreases, what happens? You go into more dense structure, okay? This is usually, I said usually, why did you say usually? What? It's not always, because water, okay? Water is very important for us. Water is important, especially when we talk about pure water, okay? I'm talking about pure water, H2O molecules. And then what is the difference in water is that when the water is changing from liquid into solid, the density doesn't increase, it decreases, okay? The highest density that you can find in most of the materials is the solid. But in water, H2O molecules, it's because of its spatial chemical properties, is what we call as the hydrogen bonding, its spatial structure. And then the highest density of H2O molecules is 4 degrees Celsius when it is in liquid. So when it turns into solid, what happens is that density decreases. When it turns into from liquid to gas, okay, the density decreases, okay? So strange thermal expansion, what happens is the particles are moving away from each other. That's what we call, when you supply energy, that's what we call thermal expansion. Water contradicts this idea when it is heated from 0 degrees Celsius to 4 degrees Celsius, it actually contracts. So which means that when you cool down water, what happens to the water? It contracts, which means that the density, okay, decreases, okay? And then water is the most dense at 4 degrees Celsius. Is it like that? Yes. For example, if you have a glass of water and if you put some ice inside, what happens? It floats on the top of the liquid. But in normal case, what is supposed to happen? The solid substance is supposed to sink to the bottom because it has higher density, okay? The one has higher density is supposed to go down, but it doesn't go down, it floats on it. Why? Because this cold water, usually at 4 degrees Celsius, has higher density than solid because of water. Other substances, it will just sink at the bottom. And where do we see this? Is this explanation, this example we usually see on internet. If you search, you can find. This is why the fish can live in a lake that has ice on top of the water. At the bottom is 4 degrees Celsius. So what happens is that when it is winter, okay, not like in peak conditions, like you go to like Canada, USA, or Europe, or Russia, it's very cold outside, like below 0 degrees, like 10 degrees below zero, like negative 10 degrees Celsius, okay, outside. What happens is that this air, cold air outside, is going to interact with the surface of the water. and then it's going to form ice. It's going to get frozen. When it gets frozen, what's supposed to happen? Normally, if it's like other particles, it's supposed to sink, go to the bottom of the container, but it doesn't go to the bottom of the container. What happens is that, okay, it floats on the water. Why? Because just the water at the bottom, okay, bottom of the ice is 0 degrees Celsius, but mostly the water inside of this lake, for example, imagine that this is a lake, okay, is 4 degrees Celsius, okay, and it has the highest density. And then that is why the fish can survive here. Imagine that, okay, when the liquid H2O molecules turn into solid and then the density increases, what will happen? These ice particles will go down, sink at the bottom, and then there will be ice in the bottom. And then again, when more water, liquid water, it interacts with the cold air outside, it will get frozen. Again, it sinks, and then whole lake from bottom to top will get frozen. But because of the spatial property of water, I just did lots of drawing. What happens is that when the surface is frozen, because it interacts with the cold air outside, so what happens is that it gets frozen, and then it doesn't sink because the density is lower than the liquid water when it is like 0.4 degrees Celsius. And then what happens is that it floats on it, and then it actually creates a protection layer, and then so it's like isolation, and then the cold weather cannot go through. And then what will happen is that, and then underwater, okay, especially the bottom part of it will be around 4 degrees Celsius. That's the highest density of H2O molecules when it is in liquid. And then the aquatic life, like plants and animals, can survive during the winter. If it is not like that, what could happen is that it would start getting frozen from water, okay? And the old fish can come up, and then they will get frozen at all. And then next season, you will not never ever see an aquatic life. It won't be possible, okay? So this is the spatial case of water. For other substances, what happens? When it gets frozen, it will sink to the bottom into its liquid. But for water, it is not like that. Okay, I'm not going to go into details. This is the natural. Okay, what about the density? Okay, I'm just going to talk about this quickly, and I'm going to ask you to complete the worksheet that I'm going to give you. Okay, it's about this, and the next class we will carry on with this, talking about this thing. Okay, as you can see, there is a table here. What is given in this table? Okay, I'm going to attach a worksheet number 5. Please, by using this information that I'm discussing now, you can answer the questions in the worksheet. Okay, so densities of aluminum is given. So which means 1 centimeter cube of aluminum is 2.85 grams. Okay, brass is a mixture of different metals, and then we have the copper. Okay, iron, lead, zinc. So which means that if you take 1 centimeter cube of zinc, so the lead, it is 11.3 grams if you put it on scale. And the first question that we can come up with, okay, calculate the mass of each material in the table below. If you have 10 centimeter cube, what is the mass of 1 centimeter cube? 2.85. What will be the 10 centimeter cube one? 10 times of it. So 10 times 2.85, it's going to be 28.5 grams. So 10 centimeter cube will be, okay, 10 centimeter cube will be, just trying to write by using my mouse, okay, it will be 28.5 grams of aluminum, okay. What is that? That's 10 types of it, okay, similar. What about zinc? I can show you, explain the zinc. So if you have 1 centimeter cube of zinc, what is that? 6.62 grams. And 10 centimeter cube, 10 times of it, okay? 10 times 6.62 is going to be equal to 66.2 grams, okay? It's going to be 66.2 grams, okay? That's how we can find the mass. What about the second question? Okay, I just would like to explain the second question also. Calculate the volume of materials in the table above. If you have 100 grams, what you need to do is that you just need to use it, for example, for copper. If you have 9.1815 grams, it's 1 centimeter cube. 100 grams is 100 centimeter cube. What do I need to do is that, okay? And then I need to use this ratio. So what we will do is that if you have 100 grams, so that's going to be 1 times 100, so that's going to be 100 divided by 9.5. Okay, I'll just take you to the calculator. 100 divided by, look at the calculator please, I'm just cleaning up. 100 divided by 9.15, okay? So that's going to be equal to, sorry, 10.92 centimeter cube. So which means that 10.93, if you round it to 2 decimal places, 10.93 decimeter cube, sorry, centimeter cube of copper, centimeter cube of copper is, just trying to know this, 100 grams. Okay, that's how we can find the second one. Okay, so what I want you to do is that, okay, we are almost done. Okay, okay, I want you to use this table to be able to answer the questions like this too until next class. And I would like you to compare some different densities when you look at the worksheet here. Okay, this is the worksheet that I attached, or I'm going to attach, okay, today, if it is not there. And then I want you to compare the densities first, okay, and next class I'm going to talk about these questions, okay. And then question 2 and 3 is similar to the one that I just discussed, okay. That's for homework until next class. That's your homework until next class. That's what we need to do. So when the time is up, we are not going to come back.